we're gonna talk about generation and recombine today. Generation means the process of creating electron hole pair or exciting an electron from valence band to conduction band. And recombination means a process by which an electron from conduction band is moved to valence band. And there are two types of generation over here. The first one is band to band. It goes directly, the carrier moves directly from valence band to conduction band. But if two-step process, in the case of two-step process, they are another states of donor or acceptor. So this carrier move into two-step. So it is called two-step process. And if it was the case of the energy move into the shape of heat, but if the energy moves into the shape of optical, the name of the concept is change into the absorption or emission. Absorption means is same as generation, and emission is same as free generation. And this is the plot of direct bandgap material and indirect bandgap material. In indirect gap material, if the energy is same as energy gap, the carrier can jump into the conduction band. But in direction band gap material, the energy is needed that is bigger than energy gap because it is indirect. So energy gap size is like this, and the energy we need to jump into the conduction band is like this. And then yes, let's talk about continuity. There is semiconductor, and if the currents flow like this, we can get equation like this. This is for hole and this is for electron. Hole generation and electron recombination. Yes, it was the case of p-type semiconductor. And if we look at the minority carrier, we can know the lifetime of that carrier. Yes, so if we look the semiconductor like this, then only minority carrier can observe. If we put in the n-type semiconductor, we can observe hole, and we can if we put p-type semiconductor, we can see electron, the recombination of electron. And then yes, and into this process, we can get this equation eventually. And if we see this equation detailedly, there is exponential, so we can know this shape up, this exponentially come down. And for silicon, the differential length is, if it is slightly doped, it is very long, and if the semiconductor is heavily doped, it is very short. We can know that by this process. Thank you.